Alors, on va commencer cette table ronde.
So we're going to start this roundtable on artificial intelligence. First, we'd like to the FMES for allowing us to speak together about the issue of artificial intelligence. Is it a revolution or a strategic evolution? First of all, I'm going to give a quick introduction to define very briefly the two main terms we're using in the scene question, which is artificial intelligence and revolution, or a strategic or military evolution. First of all, a quick definition of artificial intelligence. This is an area of scientific and technological area of research, a set of theories and techniques which make it possible by means of complex computer programs for machines to simulate certain traits of human intelligence, such as reasoning and learning. It's a field of application which is nourished by other scientific disciplines, IT, obviously, and mathematics and statistics, also cognitive psychology as well, which are intended to make it possible to create mechanisms similar to human mental mechanisms in the fields of perception, understanding of problems and situations, and decisions. So we often focus in newspaper articles about the question of autonomy. In fact, the objectives of AI are much broader than that. They make it possible to automate complex and repetitive tasks, to resolve complex problems, and also to predict behaviors and changes. It's not just autonomy that is in stake here. So that's a quick definition of AI. Now, concerning the other term that concerns us, what is a strategic revolution? Here I'm going to take a little bit more time. In historic science, a revolution is a sudden change according to the question of the existing situation, with stopping of political, economic, and social continuity. In France, the reference here is the French Revolution, the taking of the Bastille in 1789. For historians, this is a very interesting example. But in reality, the idea of revolution came about with the beheading of the Charles I in England in 1649. The English were ahead of us in that sense. Historical research shows that a revolution is always a period where there is an acceleration of change, and this acceleration often takes place with involves a lot of violence. It calls into question the existing balances. This revolution will make it possible to introduce a new kind of situation, which is completely different from the previous situation. This concept of revolution is also present in military history. We have research work in the 1950s. We have a problem with another microphone.
Messieurs les directeurs généraux,
So, I think we have the output from another room coming into our room, which is a bit weird. Unless there are some generals at the table, I don't think there are. I'll carry on and try not to be interrupted anymore. So, j'ai plus de son. At Geoffrey Parker at the end of the 1980s, which involved changes in weapons and techniques and organization of armies. This is a change of technology, tactics used by armies, and therefore the foundation itself of the military power of states. In general, these changes had impacts on societies and on their economies. It's an overall change which has many different facets and has extremely wide-ranging impacts. It's not just a question of the introduction of new technologies into military systems. In fact, a military revolution means a modification in the way you wage war and you conceive of war. And it has economic consequences and consequences for the organization of society. Therefore, we have a concept which highlights the idea that upheavals that enable a military revolution to take place normally take place over quite a long period. It's a bit counterintuitive. When you think about a revolution, you always think of a very fast change. This isn't the case in history. For example, we talk about the Neolithic Revolution. The Neolithic Revolution took place over several thousand years. Changes can be very gradual. There's a big difference compared to this last term of the in this roundtable revolution. A military revolution involves a process where there's an acceleration of change. And in the same way, these changes are linked to the changes taking place in society, which is not necessarily the case for an evolution, which when it takes place in military sphere, can be independent of changes taking place in society. So it's a very wide-ranging scope to try to answer the question. We have 3 experts in roundtable. There's no particular order here. Renaud, I'm going to introduce you first. Renaud Bellais is institutional advisor within the MBDA group. He's a doctor in political science. He's a researcher who is specialized in the defense economy and innovation in the defense field. Then we have Mickaël Brossard, is the global head of the Cortex factory of Thales. And within this structure, he runs the unit dedicated to AI, artificial intelligence. Finally, we have Éric Papin, who is a technical director within Naval Group. So he has a lot of responsibility, leads the technical innovation within all of the activities of the group, which means he's in the executive committee of the Naval Group. So first question for you, the 3 of you. I'm trying to move forward fairly quickly. Behind the concept of artificial intelligence, which in itself, the name itself is a subject of debate, behind this, we have multiple approaches and tools which are nourished by different disciplines, as I said. Artificial intelligence, in reality, is more a field of theoretical and practical research rather than a clearly defined technology. We have different branches, which can be symbolic, connectionist approaches, statistical approaches, which are the main approaches. And in each of these approaches use models, different tools, different models, which, depending on the military functions and applications that we want to improve by means of AI. And this diversity also concerns military functions, which can be supported by AI. This is a non-exhaustive list. ARID has made it possible to develop techniques for learning, to analyze larger volumes of documents, or to multi-sensor systems and the area of health and logistics with the predictive maintenance, and in the area of C2 with fusion and presentation of data in command centers. Well, there are many different examples which demonstrate that AI is a technological family with a very broad area of use. And in that context, gentlemen, I would like to ask you to illustrate this capacity that AI has to transform the different areas of military functions and to obtain improvements in efficiency. My first question will be to ask you to give us a presentation of AI systems developed by your groups, which for you make it possible to give the best possible illustration of AI's capacity to improve or to even transform certain military functions, and so that you can explain to us quite quickly, unfortunately, the benefits that can be attained compared to the previous situation, so that you can illustrate in what sense there's a greater operational capacity thanks to AI. Thank you, Frédéric. For MBDA, we produce missile systems. I would say that these changes, acceleration, and revolution, we have all three at the same time, with timelines that aren't necessarily the same. In 3 points, to sum up, we've been working on AI in missiles for a long time. For example, for cruise missiles, they have to be able to manage their trajectory and mission over several hundred kilometers with very strict constraints. And very quickly, we have integrated into these functionalities AI systems with algorithms and also the different versions of missions. So, for example, for the navigability, it's very useful to have systems that enable the system to know where it is in space, or to be able to process images. This is very different from a robot. This is something that started to be used in the 1970s at MBDA. This is an important thing because the techniques make it possible to do new things, and also from the point of view of the changes in warfare, because we've seen in Ukraine that there are non-permissive areas. So we can no longer necessarily remotely guide missiles. We have to be able to give them certain autonomy, to be able to manage the mission themselves and to enter non-permissive areas with very aggressive context in terms of communication and maneuvers. That's the first dimension. I think there's been an acceleration. We're now able to do things we weren't able to do before with computation capacities we didn't have before, because the algorithms are one thing. You have to be able to process the data and have a software that can be embedded in the missile. And the missile there isn't much space in a missile, a bit like a submarine on a different scale. That's the first transformation. We have changes in technology and in the military context, which means that it is now necessary. Of course, you have ethical aspects that have to be taken into account. Certainly in Ukraine, this acceleration has been much faster because the functional requirements that determine the technical changes. The second thing is transformation in production and design. We've seen that war economy have several things at stake. You have to be able to facilitate and accelerate things. AI can help us with design and production management. That's very important if we want to accelerate production, and also if we want to adapt our capacities to new use cases. How we can better respond to provide assistance with production and design are very important. The third dimension I'd like to emphasize is that you can always improve a missile. You have to improve the way it's used so that the final objective is achieved. So here, this is a very important transformation where AI will be able to improve management of the means and optimize responses, because we can see in Ukraine, the Russians use a lot of different means to wear down the air defenses and to exhaust the resources. We have to avoid this. So by optimizing use of resources is very important, therefore. So we've seen a transformation of the scope that is involved. The object itself cannot change, but we can improve its value through AI, which to improve the way the missile is used. For example, the DDA has increased. We've increased a startup called Diode. We're producing software that will improve the value of missiles. For example, anti-tank missiles. How can we make an anti-tank missile more effective? We can take account of the operational context to do this. The problem of war is uncertainty about the context and the environment within which this missile is operating. The idea here is to help armies more globally, more generally, in a specific theater of operations. Thank you. I'll carry on. Just to give a context, I'm in charge of industrialization of AI in the Thales Group for the products and services. The question is exactly that. What is the impact of AI in products and services in tomorrow's theaters of war? The phrase I sometimes say is that I add spice to a dish. I'm not a dish itself, a plate of spaghetti, for example. I'm something that gives them more spice and more taste and more impact. At the moment, we're not at the stage of a revolution. It's more a question of evolution, of gradual change. Can you hear me? Okay, yeah. First and foremost, AI is a question of building value. It's a question of speed. We all use ChatGPT. We all are aware that in a few seconds we can get an answer which is more or less correct based on a very large database. Occasionally this gives you better insight, and we have to work on that. And there are other challenges as well. Now, if I'm going to give you a few examples of what we are doing today in production, of course, there is everything to do with AI around amplification of Thales sensors. Let me give you a few examples. If we look at the Rafale aircraft, we have an electronic module called Spectra, which captures millions and millions of data pieces. Lots of data that is very difficult to understand, and AI, in a few seconds, is capable of sorting and preparing the work for an operator. We'll come back to this later, but one of the principles of it for us is that the human being is always in control. AI will offer solutions, and then what we're doing on this subject is AI offers a solution, and the human makes a choice. So our aim is to focus our attention, focus the operator's attention on what is the most important. We're also working on a pod we call Thales on the Rafale, which is a special kind of camera. This super camera, as we call it, is tasked with identifying points of interest, which previously was done by the pilot. So this removes the cognitive load from the pilot so that they can focus what is really important for them. The third example is that we have many different threats now, especially drones. We need to know whether it's a drone or a bird, for example, on the radar system. We need to know that. And so, again, we use AI to remove ambiguity. That's very important. The radar systems can be on vessels or on land. So that's 3 or 4 very concrete examples I've just given you of Thales systems. Then we also work on subjects of drone autonomy. This is a very interesting area of research. For the drones, we work on subjects to remove the fog of war. We have SIN drones that fly at a level where the humans cannot hear them. And this makes it possible to build a tactical solution. Do I have a section? What is their attention of the enemy? What's going to happen? And this has been proven in the ground, in the field, with very positive results. Then there's also the question of swarms of distributed intelligence, which can be reorganized according to the context. Here again, I think we're at the stage where we're working on this. It's a work in progress. What we're seeing in Ukraine is not yet being used. Then also we talk about C2, the command centers, where for echelons that are tactical or strategic, it's the key concept here is speed. This is what we see in Ukraine. It's the speed of development of software, for example. It's a question of a few weeks to obtain something rather than a few months or years. I've heard that in 3 weeks we are able to change our operation concept. Previously it took 3 weeks. Now it's something that's changing almost every day. In one day, we're capable of changing our tactics, and we're capable of introducing new functionalities in 3 weeks. Everything I'm saying is talking about the speed of war. This is the tempo or the rhythm of war, and this is very important. For us as humans, what is our reaction time? In the eye, it's a few 100 milliseconds. For the air, it's 30 milliseconds. If we have a system is able to do something 1 millisecond, this is a difference. It's a question of the speed of reaction. It's a question of tempo. We have to be up to speed. We have to be at the same speed. This is a contribution from AI, above all, is speed. At the moment, we're still in a phase where there's no tipping point, no disruptive tipping point, not yet. For us, as far as we're concerned, I'll start by talking about one subject, is AI for the profit of engineering companies and production, tests and maintenance. Of course, This is a subject where there are huge disruptions taking place. For example, for me, this is a revolution on the control of knowledge. AI, the LLMs, and the capacity to manage huge amounts of data make it possible to bring the right data at the right time in the right place and to avoid errors and procedural errors in particular, to make sure we know how to repair something and to use all of the knowledge acquired by our predecessors and put it at the right level. That's an important point. I'll move on more to the defense applications and distinguish two areas. One area is what happens on land, and the other is what happens on vessels. The revolution, as my colleagues have said, is the volume of data of different kinds that is arriving on for vessels. This data are generated by when vessels move during operations. These data are not exploited. They are siloed in the systems, and the AIA makes it possible, provided the networks are available on the vessel, to make these data accessible to the crew so that they can analyze the data and can combine them. This is an absolute disruption, a real breakthrough. So it means that in real time we're capable of mixing data from systems which today do not talk to each other. This means we can create added value for the crew that are running the vessel. It can be for optimize energy use. It can be to optimize operation of the vessel, to depend whether we have a nominal target or it's just a low-level signal. We can also detect equipment failures and immediately demand support. That's the first point. The second point is the capacity to resist when faced with new threats. This has been said already. Threats are in particular drones, which are a new threat, which weapon systems have not necessarily been designed to combat. We need to put in place new doctrines to be able to detect and classify and identify and propose a solution to the crew very quickly. And from what has been said, here we're able to have the capacity to benefit from more intelligent sensors. That's the work of our colleagues in charge of sensors. And of course, this is very valuable for us as architects and integrators. It's something we're going to use. It also, our role is to combine the data from different sensors to be able to enrich them and there again, we are creating value in for fighting against drones and non-symmetrical threats. We can use radars on the vessels that have been set up specifically for anti-drone solutions. This means we can discriminate between a drone or a missile, and we can offer the right solutions to the crew. This is very important, and it's real added value. The other point I wanted to mention is drones. In the naval field, there's been a real explosion in the use of naval drones, whether it's on the surface or underwater. And of course, the decisional autonomy of drones is a stage that goes together with remote operation that you have on certain drones, which today can travel for huge distances, but controlled by humans, which remains possible. For example, if they're surface drones, they can be in constant communication with land. In the case of drones, in case of underwater drones, communication in real time is not possible. And so to carry out missions with a real value, we have to be able to have operational autonomy in the drones. In other words, they're capable of carrying out a mission to go from point A to point B, to know whether they need to be refueled, whether they need to communicate, to know their payload at the right time, and to come back to deliver the information they've been able to obtain. That's extremely demanding, and AI makes it possible for us to do that. The other point I've talked about, distinguishing between on board and on land. Even if we can analyze data on board the vessels in real time, we can capitalize even more on the data recorded during operations on the vessels, and we can combine information from different sources and on land and in the labs of the DGA of SSF. We can describe information which will then be used by the vessels. I would say there's definitely a revolution on generative AI and in big data, and a revolution also in the capacity to deal with threats which are completely new today. Thank you very much for those examples, many examples, in fact. So we're talking about the capacity and of AI to transform very diverse military functions, which makes it possible to avoid attrition. It increases the tempo and improves the data management, which previously was siloed and not exploited. It makes it possible to have adaptations to new threats and to have autonomy of decision-making. So it's a very broad area of many, many different advantages. However, although AI makes it possible to increase effectiveness in all of these different areas, its development and implementation sometimes are subject to limits and barriers. Based on your experience, could you give us some examples of factors that represent the greatest hindrances to the development of these tools that use AI in the defense field? When I say barriers, I'm talking about they can be technological barriers, sociocultural, financial, legal, etc. And also, can you tell us what are the consequences of these barriers? I'll perhaps carry on. I think the first one is our collective slowness. We're very good at creating proofs of concept and creating minimum viable products. However, scaling up, equipping a fleet with systems that are operational is another question entirely. We're not moving forward quickly enough. And I'm not accusing anybody. I think all of us collectively have some responsibility for this. I think this is one point we need to deal with. This slowness is due to several things. As I was saying, the first type of slowness is in slow access to data. The first barrier is a legal barrier, which means that the state has clearly defined that data generated by a vessel in operation is the property of the state, and nobody disputes that, except that the mechanisms then that will enable companies to recover some of the data that the system has generated in order to be able to improve the design and propose solutions is still rather slow. We're still working on this. We had meetings yesterday with the Ministry of Armies, the Ministry of Defense, to work on this and to improve this. If we don't have the data, you don't have AI. We have to remember that. The second point is appropriation. We talk about use cases, and we're asking a lot of questions. Do we have the right use case or not? My answer is let's try. Instead of spending months and months wondering whether you're using the right case, let's try it. Let's put it in the hands of the mariners. Let them try it out. Perhaps 9 times out of 10 it won't be the right use case, and we need to start again. But at least 1 time out of 10, you know you'll do something right. I was struck by a remark made by the Chief of Staff of the Navy last August, who said to me, what stops me sleeping is that there is a solution to improve the operational capacities of a vessel, but that it is not instantly on board. That struck me. And now every day I think to myself, how can I accelerate the implementation on board of solutions that are vital for mariners? If I can move on from what you were saying, Eric, I think this concept of data access is very important. There are resistances that are sociological. When you're transforming armies. When Adam Flintoff said, when you transform an army, you'll starting to stop a tank by throwing marshmallows at it. There's one very positive thing here, is that the defense mission has to be maintained. We can't bring into peril the operational capacities and have a change that is not controlled. The technological phase is very complex, but sometimes you don't have a choice. The problem we have in France is that we're not at war compared to the Ukrainians who don't have a choice. They have to try everything. They are willing to try anything. They're willing to try out things that we would not do because of our processes, validation, certification, etc. And the difficulties we have in the defense area, as you mentioned, is access to data. In fact, we shouldn't compare ourselves to the GAFAMs. Especially in a spectrum that is very easy. They're familiar with their environment. They develop algorithms that process the data in a very specific way using a very specific tool. There are several dimensions we have to bear in mind in developing military functions. First of all, access to data is complicated because of issues to do with confidentiality. You're not going to give out operational data on the Rafale on submarines to anybody. The question of access to data is essential. We have a lot of progress to make here to define the conditions within which you can use the data to train the models. Otherwise, it won't work. The other problem we have is that we are in an environment that is not fully controlled. If you are working with Google, it's very easy. Your environment is completely configured. What is inherent to war is that you are in an unknown environment. It's much more complicated to develop solutions and models. That's why we have to simulate environments and to define with the armies the different scenarios which will make it possible to develop models that are credible in relation to the environment that will the military will have to deal with. For example, you have a land robot, an autonomous vehicle. The autonomous vehicle, the environment is very easy to vectorize. You know what roads and buildings are. It's not simple, but it's much simpler than sending a robot into an environment where it doesn't know what the environment will be. Grass, for example, can prevent progress of a land robot. Here we can see the complexity is huge, and we have to take that into account. That means you have to work on co-evolution. And finally, an equipment only exists because there's a doctrine for use. So the armies have to define how they're going to use systems to define the kind of algorithm we can develop. It's meaningless otherwise.
We need to define the technical solutions. We cannot be opportunist about this. It's much more complicated in the area of defense, where we have people's lives in between our hands. Completely agree. The question is, what do we need to be able to win? And there is no silver medal in the area of defense, and so we have to be able to win. And it is true that my keyword is speed of learning. And I like what my colleague said earlier, because often I say you mustn't look at current performance, even if we're looking at startups and we say this one is good, this one's bad. Let's not look at that. Let's look at what speed people are learning, because that is what will make the difference in 6 months, in a year's time. So my question is like the Équipe de France, the French national sports team. So how do you put that team together? And the way you do it is to make sure that it has the greatest speed of learning. So we need to have the greatest data input, how we can test things out in the field. When I talk with people about Ukraine, it's all things about the front line. Access to the front line in Ukraine is the key. It makes us think about simplicity. It's the speed at which others learn if they use it. In a more prosaic, down-to-earth way, all the AI that we do need to be validated. One of the obstacles is how engineering or how you undertake the qualification, validation of an AI. The AI is not an object which is going to evolve over time, but it's how you plan the qualification of this AI. Obstacles are anxiety versus curiosity. There is fear. We need to confront this fear. How we qualify AI, how we can be daring enough. Then there's also the technical challenge, but often we quickly land on a human challenge, how to ensure that a human being, an operator, I do a lot of applied AI. So for an operator in his job, he will have an AI tool which will come to complement what he had before, so they will work in a slightly different way. And so there is work to be done on adoption, and earlier we talked about process. From 20 years ago, we know that to transform technology is 1, and technology is 2, and AI is times 10. And so AI is just a part of a process, which is the endpoint of something much more complex, and it's how we work, how we change, and how society evolves. So going from qualification of AI to a much vaster topic. But so I think looking at the learning system is crucial. To come back to a sentence or a thought which emerged earlier, it's a change curve. Today, with our change curve, where are we? Are we at shock? Are we in denial? Are we in anger? Are we at exploration? Or are we at the building tomorrow's world? So today we are somewhere on that change curve with regards to the previous discussion, and with AI it's roughly the same. I would just like to add something. There's a point which is very important to speed up one of the obstacles. There's a technical aspect which it mustn't be underestimated. We have long lead times. We're on warships which take many years to design and to build, and weapon systems which take a long time to qualify. And so we need to find a way of doing two things. One is extract the data from where they are. And on the systems which were designed 10 years ago, it's not easy. The data often in proprietary format. We need to have, it is difficult to go and get the data. The second point is what I was saying earlier, is essential on a combat management system of a frigate which is in the Red Sea and which needs to avoid a ballistic missile in the space of a second. So there we need to have imagination. We have embarked a data system. So we have a system which is not yet possible through the historic or legacy data systems, is to now to have a new sandbox system where data can arrive, where we can explore AI modules without risking losing out robustness and resilience for the warship's command and control system, weapon system. So the second point is that we need to change the combat systems, the weapon systems, in order to have much more open systems which can evolve at the speed at which AI is going to bring new solutions to us. So we need to be able to re-qualify parts of the system without having to re-qualify the whole systems. This is a technical obstacle. We are all co-responsible of the specifications and how we have fulfilled them in the past, but our new challenge is to make this change. So perhaps not in terms of engineering technology, but the way that we can decouple roadmaps is important, because these are objects which have timeframes which have completely different. AI or software is about 2 weeks. Silicon, so hardware, is about 18 to 24 months, and then a warship is something else again. So it's how I manage an object which will need to remain relevant at all moments, at all times, given that within there are elements which have cycles which are completely different. In many countries, we've seen authorities which have decided to emphasize promoting AI and to structure public policies for support, especially in the years 2010 onwards. There were programs, plans, initiatives, even strategies which officialize these public policies. 20 or so states publish these kinds of documents, more or less comprehensive or precise, of which some of these documents aimed to manage or take account of some of these obstacles you're mentioning, legislative, regulatory, technological, and managing the different timescales. And some of these states, of which France have developed these strategies in the area of defense. One of the points which emerges in these strategies is the conservation of the technological autonomy, or even technological sovereignty, in the area of AI. I would like to know what you think are the priorities to strengthen autonomy and France's sovereignty in the domain of AI and defense AI. Everything, of course, is linked. Of course, the general AI ecosystems, and then AI specific to defense, and then also at a European level. We're used to being very humble, but I would like to say that we have already done a lot in France. The great AI challenge, which gave rise to a document which structures the AI protocols for critical AI systems. There's the AAD system. There's a supercalculator, which was inaugurated early September, which allows us to do algorithm learning for AI at a secret level. There's also centers of expertise within the armed forces. There is the Signal strategy, which the French Navy has implemented for naval war. Within the APM, they're also financing. We'll see what will become of this. But there are programs, tri-service programs. I was talking about embarked data to integrate this in various places to make sure that the data arrives on the warships. We have IT training, especially relevant to AI. And so before saying what could we do, I would like to say that we've already done a lot. Perhaps to add to this, I think that, of course, there is sovereignty. It is a legal definition. It is means, but the real issue here is the control of the tools. And with the AI, we need to have a knowledge and control of the tools in order to know the effects they can have and to be able to modify them, as Eric was saying earlier. We need to avoid the risk of black boxes. The risk is to end up with a tool where we depend on a supplier and we don't know how to modify it. And that is extremely dangerous. If we look at the media, we can develop the feeling that we are completely overwhelmed given the hundreds of billions of dollars that the Americans are investing in the area, and that NVIDIA's special chips to have these incredible capacities, we could feel overwhelmed. But you need to bear in mind that the investments being done in these areas are very specific, which do not necessarily answer military needs. And so for certain functionalities, this is not what we need. There are other applications. We need, therefore, to be able to choose the domains where we want to invest in order to be relevant, to keep control of the systems. We could have a common generic foundation for models. Often we use open source models for certain applications, but the issue is what is the modification we're bringing to it. For electronic components, we don't make many of them, but we are able to modify them with Thales, MBDA, and so on. We can modify them to add capabilities to them. So the important battle is this one, is to not let yourself be intoxicated by the fact that in any case the Chinese and the Americans are so far ahead that we will never be able to catch them up. The idea is in fact that we just need to identify where we need to prioritize within the defense sphere. It's not to duplicate what is done in the civilian arena. It is to it's to focus in the right areas. We need energy, we need ability, we need calculating power, and we need research. And then we need to then compare with other Europeans to not let ourselves be overtaken, because also below a certain threshold to invest not enough or nothing is much the same thing. So we need to define the critical threshold of investment to not let ourselves be overtaken. Totally agree. Perhaps 2 additional comments to what Éric and Renaud have just said. So we believe that Confiance.ai is a very beautiful project that the French have put together with several companies, and it allows us to think about AI in a fundamental way, talk about the technology, but the methodology which today is being used for certification of AI, which is especially important for the aeronautics industry. This is not an approach that I've seen elsewhere in the world, and I think in France we are recognized for our complex systems engineering capabilities. And so what I use in my tooling, what I am manufacturing, we're putting to use all these concepts which have been created collectively. What I think is of interest is how we can move from France up to Europe. We need to think at a European scale and how we can be relevant in Europe. We see that things are moving very fast in Germany. And I think that Confiance.IA, it's now a new name, European Trustworthy AI, whose headquarters are in Brussels. There are academics from different countries who are sitting together at the table. And so how through our leadership of thought, we can emerge from both Toulon and Paris and to influence at a higher or wider level. And the vehicles are not defensive. We want to be putting forward ideas. I have a metaphor. When I was small, I used to build sandcastles and the sea always won. We mustn't have a defensive approach. It's rather more how we can be proactive, and we need to think about what would be the useful vehicles, what would be the control points. For example, ASML in the world of semiconductors is a control point in that world. So what are the European battles where we will be relevant, and how we can build a form of strategic autonomy. A point we could add is that the Équipe de France needs to be a real Équipe de France. We need to all be in the same camp. And so when the state agents, the companies, startups, innovation labs doing AI, all the people who are working on AI engines in France all need to work together. And I would like to emphasize this. You were talking earlier about sensors, combat management systems, and weapons. The idea is not to say, where will we put AI? Are we going to put it in CMS or in the sensors or in the weapons? No, you need to put it everywhere to have the best possible performance at the end. And so if we start to shoot at each other saying, well, I'm not going to go over there, otherwise they will get the budget to put it in their system, we will not be able to reach French sovereignty. Let's be a real Équipe de France. Let's work together in an environment of trust. Let's not be naive. Either the data from one entity mustn't leak to the others. However, we need to work smartly together so that at the end the armed forces win. We started to talk about the fourth question. As I was saying earlier, for the last 10, 15 years, we've seen a certain number of states structure their public policy in terms of AI, supports given to AI, and in parallel, and often linked to this public policy support initiatives, we've seen this international level develop, generalized AI across all domains, AI applied to specific domains, frameworks which have appeared, and frameworks for thought, for international collaboration, for defense. The Pentagon had created a partnership. The AI Partnership for Defense is an example. In 2020, there had been a meeting of 14 nations represented by state teams, of which France was a part. This partnership is perhaps losing momentum now, given Trump's little proclivity for international initiatives. However, we need to be able to regulate all of this. Initially, at the state level, with the autonomous systems, there are known issues, but where are we at in terms of the various initiatives as manufacturers do take part in this? You're talking about the Équipe de France. Do we have an Équipe de France in these areas? And within these different frameworks, of course, there are frameworks which lead to formal regulations, treaties, etc., or charters, certifications, i.e. soft law. but also everything with respect to technical standards. And what we see in this area in terms of Chinese, Japanese, the Americans, that international competition is playing out in this area. Each of this state wants to impose their standards because it will facilitate the adoption of their own products and services. You, as manufacturers, what is your position relative to these different trends? Coming back to the last point that you mentioned, which is a bit different to the others, I think it's a real battle. I think standardization is something which is somewhat neglected. I have a colleague engineer who says, well, standards aren't a problem, we just apply them. Well, yes, it is a problem if all we are doing is apply them. We also need to be able to define them, because that gives us a competitive advantage beyond just a military advantage. So it's also very important in the area of defense to not have standards imposed on us which don't correspond to our use of these technologies. That is a whole topic in itself in the purely military domain. You mentioned the SALA. We have been having discussions for the last 15 years in Geneva. One of the challenges that we encounter with regards to lethal autonomous systems, how can we apply international law? The issue is that we're in an evolving situation and not one of stable technology. Therefore, the states are ambivalent towards this. On the one side, they would like to stay within international military law, but at the same time, they don't want to limit themselves with regard to new tools which could potentially be useful. We see this in terms of definition of autonomous weapons. They allow certain flexibility in their usage, and that is a challenge for us. But we can do whatever we want in a way. In Ukraine, they do whatever they want. There comes a point where you need to bear in mind that we want to achieve a military effect which must lead to a political outcome. And so we cannot do everything and anything. The biggest bomb is not the biggest one. It is one which is used appropriately to make your adversary comply with your wishes. We need to bear this in mind, because all the autonomous systems and AI systems function in an environment where there are combat personnel. The combat personnel, therefore, need to be able to trust the technology. Otherwise, that would be counterproductive. Militarily, that is very important. Second point, we need to be able to put an end to the conflict. And so we need to be able to have control. And so we could say, well, we're imposing limitations on ourselves, which the Chinese or the Americans are not constraining themselves with. But that is perhaps a very short-term vision. But over the long term, we need to find a balance which allows us to have the control of the final desired military outcome and to be able to impose a military decision to have a political outcome. And so as a manufacturer, that defines our position relative to the army and to the politicians. I would also like to add that in other technologies, we're trying to remove technical constraints or regulatory constraints. So let's not be too quick to regulate and to impose limitations which could draw out the very heart of our technological edge. In terms of weapon systems, of course, that is one domain in itself. Then AMIAD is currently pushing us as manufacturers in a direction which regulates things. We can have autonomous drones where, through hybridation between AI and classic security software, we can define cases where areas where the drone has to remain, actions which it can't carry out. We must not constrain ourselves too much. I really believe in the hybridization of technologies. There's not a single AI, there's not a single technology, so it is systems architects and technological architects who need to work on this. We need to choose the technologies according to the consequences. We do it for safety, for submarines, for nuclear safety. We do that all the time. Let's adopt those methods, but let's not start by developing pages and pages of text. It will then spend decades trying to simplify. So we take part in everything because, of course, we do not want to have regulations imposed on us. So we take part in these discussions, we contribute, so doing just what is necessary and not doing too much. Of course, I distinguish what happens within companies, AI that we are applying within companies, where we're, of course, applying all the rules stated by the AI Act, where we apply it, for example, to human resources, etc. I'm really talking about the defense applications of AI, where we need to keep the capacity to have some freedom. It is obvious that we need to have a model of data, a data standard, which is common among us, and which encourage us to be able to exchange amongst ourselves and then our partners in Europe. And better we'll be able to do this, better we will be able to develop AI. Yes, we also take part in NATO working groups on the topic. However, we need to bear in mind that others won't necessarily be as hesitant as us, and we are likely to be confronted with opponents on the battlefield who do not share the same moral standards as us. We need to be able to be true to our own values. As Renaud was saying, there are things that we need to allow ourselves to do because it's possible, and things that we need to forbid ourselves from doing. We've talked a lot about the AI of autonomous systems. Autonomy and AI are two different things. We're not introducing autonomy through AI. That's an important point to bear in mind. But also, I can see emerging from this the use of standards, of APIs, of interfaces to allow us to collaborate as manufacturers, but also that can also become a strategic control point, as we were saying earlier. The Americans, of course, who then interact via NATO, and then that comes back to France, and so we need to intervene and influence through our ability to put things forward. We need to bring our grain of sand, and we need to be around the table. With regards to the different charters within Thales, we have developed an AI ethics charter based on 6 principles, which regulates the whole way in which we work. And I think it actually works very well both in France and outside of France. And I think it is shared by quite a number of different countries. It regulates everything with regard to the human being in control. So human in the loop rather than human over the loop. How do I ensure that I control my AI? There have got to be a certain number of thermometers on my AI to make sure that it is in good mental and physical health and that the outcomes are good. So that's roughly the concept. So human in the loop, cybersecurity centers. What we see today is that AI has become a target. We can target an AI. It's software. It's vulnerable. It can be polluted. It can be decoyed. It can be degenerated. It's how we can create reliable AI, knowing that it is ours, that it has not been polluted. And I removed certain vulnerabilities, which I think are intrinsic to the fundamentals of certain algorithms. So we have people who are working on this on our side. Issue of frugality, both environmental, but also in very limited environments in terms of processing power. So we have good moral values, which it can be upheld without being detrimental to the final performance. And so we apply this to research and to industrialization or manufacturing. So the host is speaking without a microphone, so the interpreter cannot hear what is being said right now by the host. As of today, I am not aware that it is going to become that. Personally, I don't see that use of it. I think today the general trend is to find a way to increase performance, and it's true that the regulatory aspect needs to be measured. We were meant to have questions appearing on the screen. Yes, here we are. So the problem, says the speaker, is that it's just the distance that makes it difficult to read with or without glasses. So just a word of explanation about the system. With this QR code, you can ask questions. These questions are reformulated to avoid them being too long, and they are presented to all of the people in this room who can vote for the question they prefer. Democracy would want me to start with a question which has been put forward by the room for Naval Group. What is Naval Group waiting for? To get access to the data being fed into the weapon systems.
We're already doing things for the tactical situation for vessels that have embedded AI. There are some vessels that are equipped, the aircraft carrier as well. We have tactical situation is sent to the onboard system, and this enables the crew, based on this onboard data, to combine this with tactical data and to enrich it. It's true that at the moment we only have that data. We have a data product. It's one tactical situation data. This is very useful in itself. Everything that concerns the naval force. But it's true that it's not all of the data that arrives in our combat management system. You could say the same thing for the platform as well. We talked about connectors earlier. It's a bit technical. The data, in some cases, the data are in the proprietary form. The systems we have on the vessels today were not data-centric. The second thing, if you do one version for your combat management system, the changes made to this version, the data model can change. And you have to change the connector as well. We are aware of the problem. What is Naval Group waiting for? In other words, they're saying you're late. What are you doing? We have to explain why this is the case. I'm not taking it as a criticism. I'm perfectly aware of the situation. I want people here today to understand the challenge. For Naval Group, imagine, I was saying earlier, I was talking about sensors and detectors and actuators and diesel engines, turbines, lots of different things. It would be very, very useful to have their data as well. Imagine that there are data circulating about the systems on the vessels. We display them on screens. The crew can intervene. This only represents 5% of all of the data generated by systems on a vessel. So what should we send to this server that is capable of exploiting the data? Should it be all of the data generated by all of the systems all the time? Or should only part of that be used for use cases which we feel are the most promising? That's where we come back to what I was saying earlier. Let's start by trying to do things. Let's identify the most relevant use cases, and then on that basis, to be perfectly honest with you, I have a meeting tomorrow here with my teams here in Toulon on the subject of connectors. We're trying to accelerate the solutions. Today we can't put connectors on all of the vessels because all of a sudden we have some available. We have to take advantage of the technical overhauls, and we have to make sure we're not going backwards as well. That's the real life of a operational system. And the owner who isn't there, his aim is not to use the vessels as research labs. We have to bear in mind that there are constraints as well for exploitation of data. Not all data is necessarily useful for a mission. If you have too much useless data, it's no point at all. You're deviating the system, you're reducing its reaction time, as Mickaël was saying earlier. Speed is absolutely vital, which we can obtain thanks to AI. If the system has to process too much data, first of all, that takes too much time. It also costs a lot of money. The computation capacity is being used for something that is not useful. Then again, in most defense systems, you have a limited amount of energy available. So you have to find the optimal solution to balance all of those requirements. You shouldn't be just focused on data and data production alone. The objective is an operational one. It's not just to produce data for its own sake. I'll take the second question. Could AI development be slowed because of ecological standards and issues? This comes back to what I was saying about energy. Any consumption of the LLM models that have been developed is absolutely huge to consumption by the chips and by the other system. The GAFAMs want to open up new nuclear power plants just to generate enough energy for their systems. So we have to look at the needs of the army as well. We have to look at the type of algorithm we need, and we have two types of approach that are possible. This is the same for all the systems we're talking about today. First of all, do we embed algorithms on systems or subsystems, or do we have a cloud where we can redistribute the data after that to the different platforms and to the weapons? That's a question we need to ask. What is the optimum solution in terms of data processing, taking account of different constraints? If it's on board, this requires energy. It's not necessarily capital, but at the same time, it gives autonomy, not in terms of decision-making, but in terms of isolation from the network. Whereas if you use a network solution, you group and centralize data and then redistribute the data, which makes it easier for in terms of energy on the vessel system. This raises issues in terms of security, cybersecurity particularly. So there are different choices we have to make. There's no obvious choice, and the decision has to be made taking account of strategic requirements. The speaker is not using a microphone. Will these standards be determined by operational needs or by environmental standards? Well, we are dependent. You have to live in reality for a long time. Armies didn't have to take account of civil requirements, and there were some exceptions, and now we have temporary exceptions that are allowed. Maybe in the future there won't be any exceptions allowed at all from the ecological requirements. So this means that, as Eric said, we have equipment. A missile can last for 10 years, and a submarine can last for 30 years, an aircraft carrier for 50 years. So we have to anticipate the constraints that might apply in 10 or 20 years' time. For example, if we produce huge models which consume a lot of energy, and then tomorrow we say, no, we don't have enough energy, how do we operate them? We have to bear in mind that the permanence of the defense mission means that we have to have the capacity to protect ourselves and make different choices from the GAFAMs who are thinking 10 years ahead, or 20 or 30. We have to differentiate between AI and defense AI. At the moment, there's a huge amount of investment in data centers attached to nuclear power plants. Billions have been announced at the AI summit. There's a huge amount of money available to build data centers and to create computation capacity for AI and right around the world. What I observe for the time being is that the military world, we're talking about size, weight, and power. These are fundamental aspects. And the way we build our models and how we think about all of the inferences and the use of the models, we're talking about things that are extremely frugal. Seen from a distance, if I had to say yes or no, I would say no to that question. I agree. The answer is no. We have to distinguish between AI for general public and for companies. We are all responsible companies, and we ourselves, in our use of AI, we have to limit this. But when you're on board a vessel, and the environmental impact of the French military fleet on the environment is quite small, I think. Let's not start creating obstacles. The real question is, what computational capacity do we need on the vessels? Are we capable of installing it? My answer is yes. And so we can go ahead. We also have to bear in mind that one of the uses of AI can be optimized energy use on the vessel. And if we look at the total, for me, it's a positive one rather than negative, if we look at the overall situation. To go a little further, we can develop algorithms which will manage AI algorithms in terms of the priorities for use. We don't need to do everything at the same time, in the same way. If you have a plane that, and you're talking about management of the flight, it's not the same as managing the weapons. The defense environment is always using rare resources. I think frugality, we're much more reasonable than others. We know we don't have access to unlimited resources, and we have to optimize. We don't have a choice. So therefore, we are more virtuous than other civilian areas who can just plug into a nuclear power plant a few miles away. When you're in the middle of the nowhere without any power, logistics is one of the strengths of the armies, which makes it possible for the army to continue functioning. But it's always constricted. There's a big risk the power supply might be disrupted. I'm thinking of fuel supply for aeronautics is a major challenge when you go to a country and you can't just go to the local fuel depot. Okay, so many constraints that apply to defense. We are very virtuous in the defense industry, they say. The first question is a very popular question. We come back to the question of sovereignty here. We've already talked about LLMs. We've already mentioned that subject. What do you think of the encouragement to use French or European LLMs, such as Chat from Mistral instead of ChatGPT? Is that part of the sovereignty discussion to systematically think of using European or French solutions rather than others? The answer is yes. What I can see on the subject of LLMs is that if we look at Canada, they are pushing to use COIC, which is a local LLM. In the Middle East, there are Arabic LLMs. Each country today is trying to develop its sovereign LLM. Which I think is incredible is that Mistral has succeeded on a European level. I think we can be proud of that. And we have to support it. In England, people say Mistral is good. In Germany, people say Mistral is good. So I think that's very good. So that's the question of sovereignty, and they are connected at a very high level. They're also supported by NVIDIA, who helps them, which gives them a dimension and a presence outside France. And personally, they are very good when you're talking about frugal systems and data connectors. They have a catalog which is very good. So apart from the sovereignty aspect, there's also the aspect of performance. And on a personal level, we look at things outside Mistral concerning performance. Often the models are permissive connectors, so we can use different things. It's a very beautiful story, and we need to continue developing it. Talking about Mistral. Okay. As the representative of an industrial group, do you develop cooperation on a European scale in the area of defense AI? I would say the answer is obviously yes, because you are European groups in a way. Well, in what areas, more or less? Others more than others, some more than others, yes. In which areas is the question, and what are the limits? Without going into strategic details, we have skills that we develop between our different centers in Europe for AI. I think for Thales it's the same thing. The limit is that the armies in each country want to have a protection at a certain level. We have to distinguish between the technological solution we can share and then also specific applications where restrictions apply even between allies. This is the difference between defense and non-defense, where people are prepared to exchange and share more because they're waiting for others to improve what they've already done. This doesn't necessarily apply so much in defense. So open source in defense is not for tomorrow. Well, the principal aspect of defense is secrecy. This is the same in all technical areas. NVIDIA has a lot of cooperation programs between countries, but there are lots of physical access restrictions and digital access restrictions for people working on the different projects. It's up to the different armies to take the initiative. We seek to pool our skills, and it's up to the countries then to define areas of cooperation. It depends on the level of specificity. If we're talking about projects that are more generic, that's easier to share in that area rather than in areas that are more specific. I was going to say we can cooperate on a European or worldwide level. For example, we cooperate with India if the and we can do that on the level of algorithms, and then quite quickly get to a level where you're talking about sensitive data, and there's a problem with competition for us. For example, we are all very competitive, as you know. We either have very sovereign areas where we won't cooperate, or we have others which are more international where we are competitors. This is the case in research, because research has to be opened up to as many people as possible. When you're getting to the level of scaling up, the cooperation is not so present. The barriers at the moment are not at that level. They're at the level of recovering data and getting it out and having the right technical architectures. That's not where we are cooperating at the moment. It's a bit too early. Yes, I agree. It's true that on these concepts, it's very much a question of sovereignty. If you want a model to go across a border, that's not easy. In all of our architectures, this is a fundamental point. We want to know what are the technological bricks that could be taken outside the country, and all of the mechanisms that need to be put in place so that in the end we have a beneficial effect for several countries. This adds constraints to the way we think about the project. If you're talking about sending code for a model from one country to another, this is an area we need to think about more. The GGA needs to think about this. We are exploring this. We're in a learning phase. Which are the really fundamental elements? What makes France different, etc. It's true that today we have to have the French team and then work with other teams possibly. Just to add something, there are two approaches. Either companies develop things internally, which they share between the different countries. That's not complicated. There's also the federating dimension that can be created by European programs in the area of defense or, for example, in DIP. Then you might have a common foundation between the different countries. There are different approaches that are being developed. But here, we're talking more about a political layer here. Yes, but natively, we are in a European-wide approach. Yes, I agree. Absolutely. This will be for you, I think. What is the point of developing complex and very expensive missiles when the conflict in Ukraine seems to show the advantage of massive low-cost strikes? I wrote an article in the DC magazine a couple of years ago. I think we have to be wary of the purchase cost related to the impact we want to achieve. Occasionally, we use resources which are out of proportion because we don't have a choice. If you want to hit a Jihad drone with that Nestor missile, is not reasonable. If that's all you have on a vessel, the important thing is to protect the vessel, and not to think about how much it's going to cost. In that case, there's no low-cost solution, so the vessel is more expensive than the missile you're going to use. It depends what you want to do. If missiles are cheap but not effective, if you talked about drones compared to shells or anti-tank missiles, we can see that there is a lot of waste. 80% of the drones don't reach their target. Is it really that cheap? You have to think in the terms of the costs of the effect, and not the cost of acquisition or purchase. If you are going to do something that is expensive and complex for a complex mission because of the target, there's no point using a ballistic missile to strike a node in an electricity grid of Ukraine. You do that because you don't have any other resources, and it's ridiculous. It makes no sense from a military point of view. There's certainly complexity of certain systems which are not used because of the military effectiveness. It raises the question of the multiplicity of military means. Often we've taken certain choices because we've decided to use a certain missile because of the requirements related to a certain target. We can use low-cost systems that have new functionalities, and then we have to say that when you're developing a future system, complexity arises because you're going to make a lot of changes to the system, such as a fighter aircraft. For example, you can simplify a missile by transferring functionalities to defense cloud, for example, as I mentioned earlier. This is what we want to do, in a way, with the future air combat systems, with drones which will manage things which were previously on board the Rafale, because we cannot there are certain restrictions we have to deal with. These are architectural defense choices. We shouldn't be obsessed by the cost of resource. The resource isn't costly in itself. It's costly because it hasn't been used in the right way. You're not going to use your Lamborghini to go to the shop at the supermarket. If that's all you have, then you will use it. Uses can also be created as well. One thing I like, we have to nest our different industrial resources. The way that war will be waged tomorrow will be different. What context will an object be used in the future? I don't know what the future holds, but I think it's a good question. We have to look at the different forces that are being developed industrially to look at what is the best solution for each situation. It'll be a combination of two, but in which proportion, I have no idea. I'll take the last question now, but the answers have to be very quick, because I've had very firm instructions to finish by midday. With the rise of AI and digital warfare, are we going to have wars with less men in the field, less soldiers in the field? This is one of the objectives that has been described, in particular in the naval area. So less people in the crew and more experts behind their screens. Is that what's going to happen in the future? Is there going to be an internal revolution with a stronger digital culture and especially training being required within the armies themselves? I think we have to be careful about the impact of this sentence. For me, we're not going to have vessels with less people on them. The impact of data and new threats and everything that has to be done with the systems becoming more and more complex, we need to have lots of people on the vessel. But they won't be doing the same thing. This raises a question of the relationship between the crew and AI and the drones. You know that when you don't want to send a drone to the coastline, you send a submarine. Instead of a submarine, you could send a commando team or a drone. In other words, we're protecting people where the risk is highest. And if we can do that with AI and with drones, all so much better. However, on the vessels, if we automate certain functions, you get quicker decision-making. That doesn't mean you're necessarily going to have less people. You're going to have people with a different profile from today. I remember when I started on the Cenotype Triumphant, we had 116 people. There's one person in charge of instruments. The instruments, in this case, were controlling the robots. Today, everybody knows how a PLC works. Tomorrow, it will be the same thing. There will be specialists in networks and architectures and service platforms and clouds and microservices and the data models. It's going to change their training. They will be performing tasks that will be more interesting, but they will be highly responsible if something unexpected happens. It's a question of learning. AI learns from the past. It can predict a little bit, but the crew will be there to anticipate the uncertain because they will have the mental capacity to do that instead of getting them to do basic tasks, which AI can do instead. There are some misconceptions about the robotization of war. People think of the Terminator film, where robots fighting each other. The reality, we have a demographic problem in many countries. If the Chinese or the Poles are robotizing their armies more and more, it's because they don't have enough people to fight. Or Israel, for example. A lot of countries are thinking about this because they will be supporting the fighters. This is what we're talking about. We're changing from a system where you have operating of a resource, where you'll have systems that will be partly autonomous that will perform tasks. You're no longer in a system where you have supervision to define the task and perform the tasks. So it's a transformation of the approach to how the armies function. This means you also have to accept a certain level of autonomy. The reconstruction and reorganization of the armies is based on control of decision by the chain of command. This means you have a lot of centralization. This is central networks. This is in the 1990s. People said there would be ultimate decision maker who would be able to make all the decisions. In fact, that's not what's going to happen. You're going to have supervised decentralization. Humans won't necessarily decide. They'll decide whether or not to authorize certain things. We'll have a change in the relationship between in terms of the needs for skills. It won't be physical force that will be the most important thing of a soldier to survive on a vessel or on the land. This will remain, but there's also the capacity to control the resources that will have a leverage effect on the action. Quantitatively, they will increase the impact. The NGCRS, FKS, the changes in naval drones, all of this means that we have an approach where we need to have an inhabited structure that will control the means and will cover a larger area and will transmit the violence without exposing the human. We have to see it in this way. But it's not a situation where man is being replaced by a machine in the military theatre. Unfortunately, I have to bring this session to an end. We won't have time to answer another question. I'd like to thank all three of you for your explanations, which have been extremely interesting. And I would like to thank you, the audience, for your questions, which were very interesting. Thank you very much.